So what we're going to do is read through this here. All right. Make sure we're feeling pretty good. All right, so 21. It's 21 because there's earlier questions to this too, but I wanted to look at these because again, these are like the constructive responses and stuff like that. These are the parts and things. So I want to make sure we're okay with this. All right, number 21. Your mom has decided to design a triangular garden with the dimensions shown below, with x plus 1 representing the base. Okay, so there's our triangle here. Okay, x plus 1 is the base, and we have then 2x plus 3 is kind of like the height. Okay, but again, we're kind of like looking at it from the top down, right? So this is like a top view of the garden, okay? It's like we're up in the air, we're looking down on the ground, and that's what the triangular shape is for the garden, okay? We want to first determine the area of the garden in terms of x. We'll simplify our answer and then show or explain our work, okay? So we'll be showing work here. Right? So area, all right? This shape is a triangle, so we're going to try and find the area of a triangle, all right? So what is the area of a triangle? Area is what? 1/2 base times height? Yeah, 1/2 base times height. Exactly right. Okay. So, okay. And in this case, right, what is our base? What is our height? Yeah, Cheyenne? Yes. And the height is? Yes. Great. Okay. The directions also tell us to simplify our answers. What would that mean in this case? What should we do, you think? We substitute in the parts, but what should we do to simplify this, you think? Yeah, distribute, okay? So the 1/2, okay, I'll go ahead and do that one first. So the 1/2 is going to multiply, actually, you know what? I might hold off on the 1/2. Well, no, it's going to be yucky otherwise too. So I'll go ahead and distribute it, okay? So 1/2, I'm going to distribute it just to the x and to the 1. You don't have to distribute it to this as well, right? If I do 2 times 3 times 4, the 2 doesn't multiply with the 3 and the 4, right? The 2 only multiplies with the 3 or the 4, right? You don't do it to both, okay? And the same thing is true here. We have 3 things that are being multiplied, so the 1/2 will only need to multiply with the x plus 1. So that'll give us 1/2 x plus 1, whoops, forgot the x, plus 1/2, okay? And then we'll still have the 2x plus 3. And then to multiply these together, well, you can use FOIL, right, or the distributive property, okay? Whichever you guys prefer. What do you guys prefer? You guys prefer FOIL, or do you prefer like distributing here? Anybody? Distributing? Okay, so I'll do this times the 2x and that times the 3, and so I get 2x times 1/2 x plus 1/2, and then plus 3 times 1/2 x plus 1/2. I'm running out of space. Okay. To continue simplifying here, what do we have to do again? Distribute again, right? So it'll be 2x times that, 2x times that, 3 times that, 3 times that. I'm going to have to go over here because I'm out of space. So 2x times 1/2 x. Well, what's 2 times 1/2? 1. So it's going to be 1x squared, or just x squared. 2x times 1/2 will be what? What's half of 2x? 1x, yeah, plus 1x. And then 3 times 1/2, that's going to be 3 halves x. And then 3 times 1/2 is another 3 over 2. Okay? And then to finish simplifying here, what should we do? Yeah, I like terms. So it's going to be 1 plus 3 halves. You can do that in your calculator if you want to. Just type in 1 plus parentheses 3 halves. Okay? You're going to get, if you then do math, enter, enter, you'll get 5 halves x plus 3 halves. Okay, so there's our area. There's our area. All right. So that's just it, just multiplying that out there. Okay, now, letter B then, as moms tend to do, she has changed her mind and wants to decrease the height by 9 while doubling the base of their triangular garden. What are the new height and base? Or what is the new height? What is the new base? So New height, what are we going to do here then? The old height was what? 2x plus 3. And what are we supposed to do with the old height? Decrease by 9, right? So we'll just subtract 9, which simplifies to 2x, 3 take away 9, negative 6. Okay, so there's our new height. Okay, let's do the new base then. Doubling the base. So the new base is going to take the old base. What's the old base's measure again? X plus 1. And to double it, we'll just put a 2 in front. Okay. And then to simplify that, what should we do? Distribute. So you get 2x plus 2. Okay? And so there's our new base. Okay. Questions on any of that? And again, that's just, why does she want to decrease the height by 9? Who knows? Why does she want to double the base? Who knows? But we just do that to our new, for our old height. You take the old height, subtract 9. Okay? Actually, I guess I could put parentheses around it there. Minus 9, 2x plus 9, 6. And then here the 2, and then times x plus 1. All right, so letter C asks us to determine the area of this second garden in terms of x. Okay? So again, what kind of shape is this still going to be? What kind of shape are we still talking about here? Still a triangle, right? Still a triangular garden, right? So we're still going to have area equals 1/2 base times height, but I want you to find the area of the new triangle. So go ahead and do that. All right, I leave that one to you. Go ahead and try it, okay? So find the area of the new triangle. There's your new height, there's your new base, and there's your area formula, okay? Make sure you simplify your answer, please. So go ahead and give that a try right now, okay? See what you can come up with there. Doing it first and then go? Let's do that first. Unless you really got to go, in which case feel free, but I would like to try and finish this first. So I recommend distributing 1/2 first. So like 1/2 times that, 1/2 times that. So what is 1/2 times 2 going to be? Yeah, just x. So you can say x, and then what's 1/2 times minus 6? Yeah, and so keep that in parentheses still, right? And then bring down your other one right there, and then multiply it out. Right? Can you do that from there? Okay. So, what's the base? What's our new base? New base is 2 times x plus 1, which is 2x plus 2. Okay? So that's what you want to put in for the base there, right? And then what's our new height going to be? What goes in for h? What goes in for that? Yes, so you want to substitute those in, okay? So write that out and then multiply it out, okay? Multiply it out. Okay. You having trouble getting started?
Yeah.
Okay, so what is our new base? What you just found. Yeah, check this. You're going to sub that in for the b.
Is that
1/2 base height. Okay, and then the height.
Is that?
Yep, exactly right. So instead of h, put that in, and then just multiply it out. That's all you got to do. I'll do the same thing here real quick. Okay, so you should substitute it in. Multiply. Don't forget the 1/2 that was in front. So it was 1/2 base height. So put a 1/2 in front and multiply it out. Okay. Okay. Yeah. So you can FOIL it out if you want to. You use FOIL, or you can just do the distribution. So you can do 2x plus 2 times x, and then 2x plus 2 times minus 3. So 2x times minus 3 would be negative 6x, right? And then 2 times minus 3 would be minus 6. Basically, the big idea here, CJ, is that everything in here, both of these terms, you need to multiply with both of these terms. So you can do 2x times that, and then 2x times that, and then 2 times that, and 2 times that, and that'll be everything multiplied together that needs to go together. Okay, good job on the 1/2. That was exactly what you should have done there. Okay, that was good. Okay. So multiply it out. You can there, AJ. Multiply it out. Right? If you need help, let me know. Yes, x multiplies to both of these, minus 3 multiplies to both of those too. Okay, very good. You're looking good so far. So hopefully now, at this point, okay, beyond, or you're past the point here where you just substituted things in. All right, we want to distribute that 1/2. You can multiply the 1/2 to either of these two. So you can multiply the 1/2 to the 2x plus 2, or you can multiply the 1/2 to the 2x minus 6. Do not multiply it to both. Okay, most people I saw did the 1/2 times the 2x minus 6, which is fine. We can do it that way. Okay, so I'm going to leave the 2x plus 2. And I'll do the 1/2 times 2x, which is just going to be an x, and then 1/2 times minus 6, which will be minus 3. Okay, and so there it is. We need to further multiply, right? Because it says to simplify here. So we'll multiply this out, okay? And again, the big picture here, if you don't like this distribution stuff that I did right here, okay, if you don't like that, really the big idea is that each term here needs to multiply with each term here, okay? So the 2x needs to multiply to the x and the minus 3, and the 2 needs to multiply with the x and the minus 3 as well. Okay? Sometimes we draw it like this way. Okay, if that helps. Okay? The 2x multiplies to the x and the minus 3, the 2 multiplies to the x and the minus 3. And so we'll just go ahead and do that. So 2x times x, 2x squared. 2x times minus 3, minus 6x. 2 times x, 2x. 2 times minus 3, minus 6. Okay, and then is there any more simplification we can do there? Is there any more simplification we can do there? Yeah, minus 6x plus 2x. So we get minus 4x minus 6. Okay, and there is the new area. Okay, so questions on letter C? So we had our old garden. Our old garden had an area of this, okay? And then we made some changes to the height and the base, and we got the new garden area, which is this. So there's the area of the one garden, there's the area of the other garden right there, okay? Letter D asks, for what values of x will the area of the two gardens be the same? Show or explain your work. Okay? So, how can we represent that here? How can we represent the area of the two gardens being the same? How can we set that up? What would that look like? Yes, exactly right. Set them equal. Where they're the same, they're going to be equal, right? So x squared plus 5 halves x plus 3 halves equals 2x squared minus 4x minus 6. Okay? Beautiful. Now, what options do we have to solve an equation like this? How can we solve an equation like this? What can we do? Okay, so you want to get everything over to one side?
Yeah.
Okay, so that's one option here. Is we can like set it so you want to solve for 0 basically. Okay, do you care which way I do it, Patrick? Like as far as like moving one thing to the other. Does anyone have a preference about which one I move? Do you want me to move all these 3 terms to the right, or do you want me to move all these 3 terms over here to the left? Does anyone have a preference? Move this to the right. Yeah. Okay, I like that too because we'll keep a positive x squared there if we do it. So minus x squared, minus 5 halves x, minus 5 halves x, minus 3 halves, minus 3 halves. All that. So gone, we get 0. 2x squared minus an x squared is x squared. Minus 4 minus 5 halves. So it's a negative 4 and then take away a 5 halves. Okay. And so let's see, minus 4 is negative 8 halves, minus 5 halves, so negative 13 halves. And then negative 6 minus 3 halves, so negative 6 is 12 halves, take away 3 more, it'll be 15 halves. Okay, now how can we go about solving this? We've got it all to one side, it's equal to 0, now what can we do? How can we continue to solve here? Factor? Okay. Ugh. All those fractions in there, it's going to be kind of yucky. What can we do here to get rid of those fractions? What would cancel out those fractions here if we did what? If we, okay, so multiply the reciprocal. Yep. Or I'm thinking, because I see what you're saying there, that would cancel the fraction there. Okay. I'm thinking since they're both divided by 2, we could multiply both sides just by 2. Right? Multiplying everything over here by 2, we get 2x squared, and it just becomes minus 13 and then minus 15. And if I multiply by 2 over here, what are we going to get? 0, right? So it's still 0. So I'm going to go ahead and multiply both sides by 2. This might make it a little bit more easy if we're trying to factor. Okay? Right? That's what we get. If we multiply both sides by 2, that's what we get. Okay, that makes it much more palatable, right? All right, so to factor this, we'll take that 2, multiply it back with the negative 15, and we'll get negative 30. And we're going to look for 2 numbers that multiply to negative 30 but add to make negative 13. Yeah, negative 15 and positive 2. Okay, so we get 0 equals 2x squared minus 15x plus 2x minus 15. Okay, and again, I use these 2 numbers to break up that middle term here. I did 2 times negative 15 to get that negative 30. I look for 2 numbers that multiply that negative 30 but also add to the middle term. Break up the middle term using those 2 numbers. And then group and group. Okay? What can we pull out from that first group? What can we pull out from that first group? An x. So left with 2x minus 15. Okay. What can we pull out from this group? Silence, because there isn't anything. We can pull out a 1. Okay. And then they both have that 2x minus 15 in common. And so this is really just going to be 2x minus 15 and then x plus 1 left over when I factor that out. Okay. And then finally, what do we do here? We have 2x minus 15 times x plus 1 equals 0. So what should we do? Set them both equal to 0, right? So I'm just going to do that. I'm just going to move it over here. So 2x minus 15 equals 0. X plus 1 equals 0. Okay. So we'll add 15. We get 2x equals 15. Divide by 2. X equals 7.5. Okay. We'll subtract 1 from both sides. X equals negative 1. answers. In the context, do both of these answers make sense? Do both of these answers make sense in the context of the problem here? I would say no. If you put negative 1 in back in like our original triangle, you're going to have a side length for your garden of 0. So I would say you could probably throw out the negative 1 because when you plug it back in, it gives you like a weird side length. But 7.5 does work for both, for the x's there. And so I would say probably just a 7.5. The directions are unclear about whether you're supposed to eliminate, bad answers or not. Okay, it just says for what values of x will the two garden areas be the same. So those are the two values. So I might accept both there just because the question is not really sure. But 7.5 is definitely the better one because it doesn't, it results in an actual garden existing. Okay, now, who thinks that was a lot of work for letter D? Yeah, okay. So you guys chose the harder path. How else could we have solved this equation? Trinomial? Like, what do you mean? Okay, yeah. So you're saying like factor from here, you're saying maybe or something? A quadratic formula? That's still a lot of work. What other tool do we have at our disposal, guys? Subtraction? Well, we did. We subtracted it over there. The graphing calculator. Okay. Remember, I told you, right? I've been telling you over and over again, whenever you have an equation that you're trying to solve, okay, any equation that you're trying to solve, graph the left-hand side, graph the right-hand side, and then find the intersection points. Right, so let me show you. We'll just graph this left-hand side here. I should put parentheses on my fractions. Okay. There's the left-hand side, x squared plus 5 halves, x plus 3 halves. And I'll do the right-hand side, 2x squared minus 4x minus, okay. Graph it. There's the left side. There's the right side. Okay. And I can see a point of intersection right there. Right? There's a point of intersection right there between the two curves. There's one, there's the other. So the point of intersection is right here. How can I use my graphing calculator to find what the exact coordinates of that point of intersection are? What do I need to press? You guys know? Second trace. Which command should I use? Intersect, number 5. We want intersect. I guess in this case it is a 0. That's true. But we're going to use intersect. Okay? So if I move left and right, I can see the first curve is this one right here. That's what I want. Yep. The second curve, yep. Now I'm on the other curve. Hit enter. And then for the guess, I'm going to move my little cursor in towards that point and hit enter. And there's one of our solutions. When x is negative 1. Hey, when x is negative 1. Okay? Now it looks like the curves might intersect further up here. Okay? How can I adjust to see up here more? What do I need to do? What button do I press for that? You guys remember? How do we adjust this? The window. Yep, window. And which part of the window do I want to adjust? If I want to go further up on my y-axis, I want to adjust the y max. And let's make it 20 just to see if we can get it to make it see it there. Okay, so there's just, we moved up more there. Okay, looks like I need to move up even further. So I'm going to go like crazy. I'm going to do like 50 maybe. Let's see if that works. Ooh, we're close. Let's try 100. Aha! We have another point of intersection. Second trace, intersect, first curve, second curve, and now the guess is important. You want to move your cursor in towards the actual point of intersection we're trying to find. And there's our 7.5. Okay, there it is. Okay. Now, those are your choices. Mr. Widd, it says show or explain your work. Okay, so how would we explain what we just did there? What could we write? Once we have it set up, right, what could you write to show or explain your work that you did? What did we do? Yeah, graph the left-hand side, graph the right-hand side, and what? Find the intersection point. Boom, you're done. That's your work. That's all you got to write. Okay? You can go back from that. Thank you for waiting, AJ. Okay? That's all you got to write. Okay? So your choice, if you want to solve it by hand, absolutely, you can do it. Okay, we just did it, right? Or you can just graph it on your graphing calculator, find the points of intersection, and then just write down, I graph the left-hand side, graph the right-hand side, found the point of intersection, and the answer is at x equals 7.5 and x equals -1. Okay, that's it. Your choice. Your choice. Okay? Your calculator will not multiply out these terms, right? They will not multiply out these terms. It will not multiply out these terms here. Okay? There are some graphing calculators that will do that, but I don't think any of you guys have that one, unfortunately. All right? Excuse me. All right, let's try number 22 here. Okay, so turn the page there to 22. Well, not turn the page, move the page over. All right, we got a baton twirler. Releases a baton at a height of 5 feet above the ground with initial velocity of 30 feet per second. The height of the baton, t seconds after it is thrown, is given by the function h of t equals that. So this describes the height with respect to time, right? H of t is the height of the baton in feet. Okay, so t seconds, h of t is the height of the baton in feet. We want to graph the function here. Okay, now what options do we have? What strategies do we have available to us here to help us graph this function? What can we use? The calculator, right? That's one option. So let's go to our calculators here and type it in. Okay, my window is still messed up. If you guys like adjust your windows, if you want to adjust it back to like the default setting, if you press zoom, zoom comes with kind of like some, well, I don't even know how I want to describe it. Well, anyway, well, it's zoom standard there, okay, is what you want to use, number 6, and it goes back to the normal viewing window. Okay, let's type this in. Negative 16x squared plus 30x plus 5. Oops, I only did 3. Okay, there's my curve. All right, make sure I do that right. Negative 16x squared plus 30x plus 5. It's okay that we're using x's instead of t's. Same idea. Oh, I'll get to this paper here. Okay. We're on this one, right? Okay. Right. Yep. Yes. Did I give you a rental form?
Yeah, I just gotta get it filled out.
Okay, gotcha. I forgot. I got a few extras in case I forgot. Thank you. You're welcome. Okay. All right. Again, to graph this, we want to find our vertex first. And we can see our vertex is going to be somewhere up here. So again, I'm going to adjust my y max here. I'll go to 20, see if that makes it fit. Okay, it does. Right there it is. So I'm going to use second trace. Okay, in this case, with our vertex being up here, which command do we want to use? The maximum, right? So go down to maximum. Okay, make sure you're to the left of your maximum. Hit enter. Make sure you're now to the right of it. Hit enter. And then go up towards the top. Hit enter. And, ooh, that is not a nice maximum. Make sure I type this in correctly here. Negative 16x squared plus 30x plus 5. Darn. Okay. So let me do that. Let me do this. I'm going to make my window go up a little bit more. I'll do the maximum command again there. Just so it's not so high up. Okay, left bound, right bound, guess. All right. So we're going to have to kind of approximate this here because there's no way I'm going to expect you guys to graph this like very precisely, okay, because that's just too much, okay? So what would we say, what is this about, approximately? The x-coordinate is about what? 1, and this is about 19, or I even say let's go up to 20 just to make it easier for ourselves, okay? So our x value is 1, so I'm going to count by like maybe 0.5s down here. So I'll do like 0, 0.5, 1, 1.5, 2, like that maybe, okay? And then for the y-axis, what would maybe be a good number to count by here? I don't think we'll be able to count to 20 all the way to the top there. So what maybe should we count by here? Let's do 2s. I think that's a good idea. Yeah, 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, that's a good idea. Sorry, this is like for a different thing here. Okay? What's our x-axis going to be labeled as? What does our x or our t variable here represent, right? Seconds. Yep, so this is time in seconds. Okay, and then what is our y-axis labeled? The height. Yeah, so this is like h of t, height. And what's the units for the height? Height is in feet. Okay, and so we're going to approximate that. So we're saying it's about 1 and about 20. We'll go with 19 though. I think that's maybe a better one. So we'll just say 1, about 1, and then about 19. So 1 and then about 19. So it'll be about halfway right there. Okay. And let's see. We'll go to our table and see if we can get any other nice points there. So at 0, we're at 5. That's a nice one. So at 0, 5. Put a point. And then I don't have the 0.5s here, but I do have 2. At 2, we're at 1. So like right there. Okay? And that's good enough for me. We can just go ahead and connect the dots. If you want to get more points here, I'll show you how to do that. Since I'm counting by 0.5s down here, if you want to be able to count by 0.5s in your table, if you press second window, okay, and then we're going to change this triangle table. That triangle is actually a Greek letter delta. Okay, that's the Greek letter delta. And delta stands for change. So what this is trying to say is like, how is our table changing? Right now it's counting by 1s. If I change it to 0.5, now my table will count by 0.5s. Okay, so at 0.5, we can now see, oh, that's 16. So 0.5 is at 16. And then 1.5 is at 14. Okay, and we can kind of connect the dots there. Okay, just like that. Oh, and then speaking of, how high is the baton after 1.5 seconds? Well, we just got that, right? What is the height of the baton after 1.5 seconds? It's 14 feet, right? And I think, let me go highlight that. Yep, okay, it's 14. So there's a couple ways you can do this. You can just do h of 1.5. So it's going to be, like negative 16 times 1.5 squared plus 30 times 1.5 plus 5. Okay, and that equals 14 feet. Okay, we can also use our table there, too, in the calculator. Okay? So there's your answer for B. All right. So questions on the graph here. All right. I'm pretty sure the question on the actual test will have like the numbers work out more nicely. Okay. So that vertex was kind of like weird coordinates. There it is. All right. All right. Turn the paper over. There's a few more questions here to answer too. Okay. So letter C asks, what is the maximum height of the baton? So if I go back to my graph that I have right here, okay, what do we need to do to find that maximum height again? If I've got my graph right here, what can we do to find the maximum height? Yeah, second calc or second trace there, and we'll go to the maximum command, right? Just use maximum. It's our vertex, right? So we'll just go to the left, go to the right, hit enter for the guess. And so according to this, what is our maximum height? 1 is the x value. 19 is the y value there. That describes the height. Remember, the y values are the height. The x value is time. So that's the time that we reach the maximum height. That's the maximum height. So about 19.0625. Oh, round to the nearest hundredth. So 19.06 feet. Okay, letter D. How long does it take for the baton to reach its maximum height? What's our answer? There it's at the maximum height. So what time is that? Yeah, about 1 second. It says to round your answer to the nearest hundredth, so that's 2 decimal places. So we'll say 0.94 seconds. Okay? Okay, the next question. If she catches the baton at a height of 6 feet, what time does she catch it? She catches the baton at a height of 6 feet. What time does she catch it? Well, let's go back to our table here and see if we can see. Do we see a height of 6 feet in our table anywhere here? I don't see a height of 6 feet anywhere. How can we figure out what time it is when she catches the baton at a height of 6 feet? What can we do here to figure that out? This is like the height of the baton over time. How can we figure out when it's at a height of 6 feet? Ideas? Kyle?
We could look at where it's at 6 on the Y line.
Okay.
And then see where it is intersects on the X line.
Aha. So, but in this case, for our calculator, it's going to be kind of tricky. We can go back to our graph here and maybe try and estimate that. Here's 6 on our hand-drawn graph. And if we go over here, okay, there's where it intersects. That's where she would catch it. Right? I mean, technically, it's at a height of 6 feet here, but I doubt she's going to throw it, right? There's where she's throwing it at 0 feet. It's 5, right? I doubt she's going to catch it right after she throws it. She's going to let it come up and then back down and catch it. Okay? Yes. Okay. So, what time is this approximately? Looks like what? It's like halfway between 1.5 and 2. What would that be? Yeah. So we could estimate it, right? It's about halfway between 1.5 and 2. So maybe like 1.75 or 1.8. Okay? Not really sure. Here's another option. Okay? We want to know when the height of the baton is 6 feet. So we could set this equal to 6. Or in other words, I could graph 6, right? So there's the height of the baton at any time x. There's a height of 6. I'll just graph it. So there's 6, right? There's that height of 6. I could find where the baton is at 6 feet here, or I could find where the baton is 6 feet here. And that's what I'm going to say we should do. Second trace, intersect. Okay, first curve, second curve, guess. And there it is, about 1.84 seconds where it intersects. Okay, so we're going to take negative 16t squared plus 30t plus 5. So we're going to set them equal to each other. When does the height of the baton equal 6? Excuse me. Okay. And we get then that t is approximately, like I said, 1.84 because we're rounding to the nearest hundredth. Okay. 1.84 seconds. All right, and then last but not least, we're supposed to state a reasonable domain. Okay, so let's go back to our curve here. I'll get rid of that 6. A reasonable domain. So remember, domain describes what coordinates? The x's, right? Okay. Would we say negative infinity to infinity here would be a reasonable domain? Why not? Why is negative infinity to infinity not a reasonable domain? The graph is a parabola, right? And a parabola always has domain negative infinity to infinity. But why, in the context, does negative infinity to infinity not make sense? Why does it not make sense? Chris? Yeah, it stops, right? Specifically, where does it stop? At 0, right? And so we got to figure out what the zeros are to determine when it starts and when it stops. Now, at what time do we start? Time t equals what? 0, right? We're going to start at 0, okay? So the domain is going to start at 0 because we're talking about time, okay? And then we got to figure out where it stops, which is maybe where it hits the ground, because we don't know if she's like going to catch it or not. She's just saying if she catches it there, so we'll just say if it hits the ground, because it's not going to go subterranean, right? Which would be like what this is. So second trace, we use the 0 command, and we'll go to the left of that 0, and then to the right of it, and then in towards a guess, and I don't know, I can get close either way there. And there's our other 0. About 2.029. So we'll say about 2.03 if I round to the nearest hundredth there. Okay? And there is our domain in the context. Alrighty? Okay. All right. Questions on any of that? We're all good there? Okay. And then let's take a look at number 23 here real quick. Okay. All right, now number 23, a portion of the graph of a quadratic function, f of x, is shown in the xy plane, so there's like a quadratic or a parabola there. Okay. Selected values of a linear function, g of x, are shown here in the table. So if this is linear, that means what is this? The graph of this is going to be a what? A line. So this is a line. This is a parabola, right? Okay. So we want to find the equation of the function f of x. So all we have here are 1, 2, 3 points. Okay. We have the vertex, and we have 2 zeros here. Okay. So how can we find the equation of this thing? Let me think about this here. So I'll show you an easy way to do this on your graphing calculators, okay? To find the equation for a parabola when you've got these 3 points here, all right, you can actually get your calculator to do it for you. You guys ever remember doing like lines of best fit? Yeah? Okay. So to do a line of best fit, you would press stat and then edit. Okay, and then you'd put your line of best fit, you'd put your like stuff in the table there. Okay, we're going to do the same thing here. Okay, we've got 3 points. We got -2, 0, we've got 0, 12, and we have 2, 0. And I'm going to put those into my graphing calculator here. So -2 and then 0, 0 and then 12, and then 2 and 0. Okay, those 3 points. Then I'm going to press stat again. Okay, once you have those in. So again, stat edit, that was where you put the points in. Then stat again over to calc. And we're going to go down to quad reg for quadratic regression. This is going to create a quadratic equation from these 3 points. Okay, my x list is in L1, my y list was in L2, and I'll have it calculate. And there's our answer. A is -3, B is 0, C is 12. See how easy that is? So we'll have -3x squared plus 0x plus 12. Sorry, that looks like a T. Okay. Question? Do it again? Yep. Stat, edit. So the stat button is right here below delete. Okay. So stat and then edit gets you to your lists. Okay. Now you want to make sure you have L1 and L2. If you have information in that, arrow up and hit the clear button. And arrow up and hit the clear button. Don't hit delete. Okay. Use clear button. Just clear them all out. And again, we'll type it in again. -2, 0, and 2. These are my x coordinates. And I'll type in their matching y coordinates. 0, 12, 0. Okay. And when you're done, type it in. Let me know. Again, those are just our coordinates for the quadratic. Good. Then press stat, arrow over to calc, and we're going to use quadratic reg, quad reg, which is short for quadratic regression. It's going to do the best curve through those 3 points, and it's going to give us then just the actual quadratic. So we'll go down to calculate, and then there are your numbers, A, B, and C. And you just fill it in. -3x, yeah, you're welcome, plus 0x minus plus 12. Okay? Guess what? We can do the same thing for the line. Okay? So we're going to go back to stat, edit, clear out L2, clear out L1, -2, just type in your x values, and type in the matching y values. Okay? So x values and their matching y values. Just from the table there. When you've done and when you're done typing those in, press Stat again, arrow over to Calc. And in this case, do I want to use quadreg again? Is this a quadratic function? No, we were told it was what? Linear, right? So that means we want not 5, but which option? 4, yeah, linear reg. So we'll go down to there, hit enter. Again, my x list was in L1, my y list is in L2. That's good. We'll go to calculate. And there's your linear equation. 2x plus 4.25 gives it to you in slope-intercept form there. Okay? I leave the rest to you. So C, what are the coordinates of the points where these two functions intersect? How can we use what can we do to find where those two functions intersect? Graph them and find the points of intersection, right? And then letter D, which function has a greater average rate of change over the interval from -2 to 0? Okay, remember, average rate of change, folks, is f of b minus f of a over b minus a. Okay, it's your slope formula. Okay, so I'll let you go ahead and do those too. Or you also need to do g of b minus g of a over b minus a. Okay, so these last two questions here, C and D, that'll be homework if you don't finish it right now. Okay, now granted, you have a good 6-7 minutes here to get it done, so you should be able to get those done. At least letter C. And I'll come around and help too. Let me get the video compiling here first, though. I'll right around.
B, for B, it's 4.25.
Let me see here real quick. Sorry.